Unit 2 Forces Project. A 5 kg mass, we're going to call it M1, and a 3 kg mass, M2, are connected by a string over a pulley. Determine the tension. So our givens are M1 is 5 kg, M2 is 3 kg, the acceleration of gravity is 9.8 meters per second squared, and the acceleration in the x direction is 0 because the masses are not moving horizontally. Our find is tension. This is a diagram of the system. It is on the s-axis. Tension is upwards on the masses, and the forces of gravity are downwards. Gravity for M1 is labeled M1g, and same goes to M2 with M2g. The two equations we will be using to solve this problem are the summation of all the forces in the system and the summation of all the forces in the y direction. First, we are going to solve for the acceleration of the system. On the left side of the equation, we plug in positive M1g and negative M2g. People tend to not pay attention to the sign of the s-axis, so please take that into account. On the right side, we plug in the mass of the system, which is M1 plus M2. And finally, we rearrange it to equal acceleration of the systems. Now we can use this knowledge to solve for t. On the left side, we have positive mg and negative t. On the right side, we have the mass, which is m1, since we are solving this using mass 1. You can also use mass 2, it eventually comes down to the same answer. Then we plug in the acceleration of the systems. Finally, we rearrange it to equal to t. Now, we can plug in all the numbers to find the solution. First, we have to find our acceleration of the systems. M1g can be found with our mass givens and our acceleration of the gravity given. Same with M2g. Now you plug everything into the equation, make sure to write down all the units as well, simplify everything, and the acceleration of the systems should be equal to 2.45 meters per second squared. Next, we plug in our values into the equation to solve for tension. Plug in M1g, M1, and the acceleration of the systems, which we found to be 2.45 meters per second squared. Make sure to plug in units. After simplifying units, it should cancel out, leaving kg times meters per second squared, which is equals to a newton. So our final answer should be 36.75 newtons. Moving on to the second problem. A 7 kg object slides to the right and encounters a friction force that slows it down. Mu is equals to 0.3. Find the acceleration in the x direction. The givens are mass is 7 kg, mu is 0.3, acceleration of gravity is 9.8 meters per second squared, and acceleration in the y direction is 0 because the object is not moving vertically. The find is the acceleration in the x direction, and the miscellaneous forces are normal and friction force. So our diagram is on a flat surface. It has a normal force upwards, gravity downwards, and friction going to the left because the object is sliding to the right. The equations we are using are the summation of all the forces in the x direction, also known as max, and the summation of all the forces in the y direction, also known as ma, and the force of friction equation. First, we use the max equation, and we plug in the negative friction because friction is on the negative x-axis. Rearrange the terms to equal to the acceleration in the x direction. So now, we move on to the force of friction equation, which tells us that F is equals to mu times n. Plug that into the acceleration in the x direction equation. But now we have one value we need to find to solve, which is n. Normal force. This is where the summation of all the forces in the y direction comes into play. Plug in positive n and negative mg because it is on the negative y-axis. Rearrange this to get n is equals to mg. So the acceleration in the x direction is negative mu times mg divided by m. But wait, we can simplify this by canceling out m from both the denominator and the numerator to get the final equation of ax is equals to mu times g. Now, it's time to plug in all our givens. Plug in 0.3 for mu and 9.8 meters per second squared for g. And the final solution should be negative 2.49 meters per second squared. Moving on to problem 3. A 200 kg box is sliding down a frictional incline at a constant speed of 0.2 meters per second. Find mu. Now, this value of constant speed that they give us in this problem, it's just there to throw you off. So always make sure to look for these sort of values that are there to throw you off every time you're doing a problem similar. The givens are mass is 200 kg, acceleration of gravity is 9.8 meters per second squared, theta is 30 degrees, acceleration in the perpendicular direction and parallel direction is 0. The find is mu of the object. So for this problem, we have to tilt the axis. That's why I've drawn a dotted line. The force of gravity always points down regardless of the incline. Friction points to the positive x direction. Normal force points to the positive y direction. And now we can draw a right triangle in the section circled. mg is the hypotenuse since n is not equal to mg due to the incline. So the long leg of the triangle would be the force of gravity in the parallel direction, and same with the short leg, which would be the force of gravity in the perpendicular direction. Now, to find the value of the force of gravity in the perpendicular and the parallel direction, we will use trigonometric identities. So cos of theta is the force of gravity in the perpendicular direction divided by mg, which rearranges to mg cos theta. And we'll do the same with the force of gravity in the parallel direction, which, when you rearrange it, is equals to mg sine theta. So this is our final free body diagram. So the equations we will be using are the summation of the forces in the perpendicular direction, which is mat, and the summation of the forces in the parallel direction, which is mol, and the force of friction equation. First, we plug in the positive n, and because it's on the negative y-axis, negative mg cos theta on the left side of the mat equation. The mat cancels out to be 0 because acceleration in the perpendicular direction is 0. So n equals mg cos theta. Next, we plug in positive f, and because it's on the negative x-axis, negative mg sine theta on the left side of the mol equation. The mol cancels out to be 0 because the acceleration in the perpendicular direction is 0. So f is equals to mg sine theta. Now we can use the force of friction equation to rearrange and determine mu to be equals to f divided by n. Since we know the values of f and n, we can say that mu is equals to mg sine theta over mg cos theta. But wait, we can actually cancel mg out of the numerator and denominator, which then results in sine theta over cos theta. Sine theta over cos theta is equals to tan, so we can conclude that mu is equals to tan theta. Now we can plug in for our solutions. So mu is equals to tan of 30 degrees is equals to square root of 3 over 3, which is our final solution.